So we're going to look at a few other ways of modeling functions. In this video with the geometry, we're going to focus a little more on volume and a little bit with surface area as well. So in this first example, we have an open box. So you can see how it would lay flat on the ground, and then if you fold up the pieces, you'd have your box at the end there. So what we want to do is express volume of the box as a function of x. So volume of a box, we take length times width times height. So if we look at our flat here, we could have length, width, and height. Now height of the box is just going to relate directly to x, so h is going to be the same thing as x. With width and length, those will actually be the same thing, so we don't really need to calculate it twice, we can just calculate it once. So notice that length here is just this kind of shorter piece of the box. So what we have is this overall 30 inches, but then I need to take away x and take away x. So this length here is being represented by this overall length of 30, but take away 2 x's, so that we just get this shorter piece here. So, for calculating volume, we're going to have, let's go ahead and put in height, so that x, and then length is that 30 minus 2x, so we're multiplying that, and then we multiply with width, which is the same thing. It's also the 30 minus 2x, because we're seeing the same exact thing along that side of the box as well. So we would multiply that twice, so I would just use an exponent of 2. So v of x, I don't actually need to change much. You could multiply it out, but that's fine just like that. X times 30 minus 2x squared. What's the domain? So how are we going to limit x? So what we could think about is visually, what values could we have here for x? The smallest, and in fact we wouldn't want to include this value, would be 0. If we had 0 there, then this just becomes a flat piece of paper and we can't build it up into a box. But the idea is as soon as we have a little bit more than 0, then we can start folding the sides. So with that, we're going to start at 0, but not include 0 for x. And then, so we have these two sides that are the same, but a total length of 30. So if you imagine I went all the way to 15. So I had 15 and 15. Well, then I wouldn't have anything for folding up the box. It would be this kind of space of 0 between the two. So we don't want 15, but anything less than would be fine, like 14 inches would be fine. We'd have this little like 1 inch bend right there. We could work with that. So we don't want 15 there. That's going to be our absolute maximum value for x. So I'm going to put 15 and stop it there. So with that, it's just kind of with the visual, what numbers could we plug in that would work? And more specifically, you're thinking about when does it stop working? Alright, one more example here, and this is going to work with volume and surface area. So you're designing a cylindrical can that must hold 100 cubic inches. So I always start with drawing the picture, so let's draw a cylinder. So we're going to have circle, and then a height to it, and circle. And they're saying the volume must be 100 cubic inches. Now, volume for a cylinder, what we're going to have is, for the circle, we'll have some radius, and then for the can, we'll have some height. So the formula for volume, and how I think of this, is basically we want to take the area of the circle and then multiply it by the height. So the area of a circle is pi r squared. And then we want to multiply it by the height, so we'll have h at the end. So we have this relationship between volume, and we know what the volume is. So let's use that relationship. Express the height h of the can as a function of its radius r. So we want a function h of r. And what we just got is this relationship between we know what the volume is and we know how to calculate it using h and r. So we know that 100 is equal to pi r squared h. And to get our function, what we want to do is solve for h. So I'm going to divide both sides by pi r squared, divide by pi r squared. And that'll give me my function h of r is equal to 100 over pi r squared. So there's a relationship using the volume. The top and bottom of the can cost 14 cents per square inch, and the sides cost 7 cents per square inch. So moving to, if we look at the units for a second, cubic units are volume, square units are area. So something that we're getting at here is the idea of surface area. The surface area of the top and bottom, and the surface area of the side. So what you can imagine is if we deconstructed this can, what we would end up with are these two circles. So we'd have the top and bottom, each with their own radius. Well, they have the same radius. So we have those two surfaces. And then with the side piece here, so it wraps around, but you can imagine if we just cut through it, if we laid it flat, it would lay flat like a long rectangle, where the height, I mean, it depends on how you imagine you cut it. So, but one of the sides would be the height, and then the other side, so if we cut it and we have our height for one side, the other side would come from the circumference of the circle. So as a refresher, circumference of a circle is 2 pi r. And then area of a circle is pi r squared. So there, if you just look up surface area of a cylinder, there's a formula putting it all together. But I just like to kind of go through this deconstructed form so that if you're in the woods without the internet and you need to find the surface area of a cylinder for whatever reason, you can think of it in this deconstructed way. As long as you have kind of these more basic formulas down, they can come together. So for surface area, I'm going to add two circles plus a rectangle together. So for surface area, in fact, I'm going to write that out in words. So we're going to have two circles, that top and bottom, and then rectangle. So the two circles, it's coming from that pi r squared, but I'm going to have two of them, so 2 times pi r squared. And then I'm going to add on that rectangle, which comes from the circumference of the circle for one side of it, so that 2 pi r, and then times h for the other side. So I'm going to have 2 times pi times r times h. Alright, so this is getting at the idea of surface area, but I'm bringing cost into it too. So for the circles, that's 14 cents per square inch. And the rectangle part is 7 cents per square inch. So what I'm going to do is multiply that, because whatever area I have for the two circles, if I wanted to know the cost, I would just multiply it by how much it costs per square inch. So this function cost as a function of r, I'm going to have that 0.14, so that 14 cents, times 2 pi r squared, plus the rectangle, so 7 cents per square inch, times 2 pi r h. Now, I'm going to simplify. I have some numbers I can multiply together here, but I also have too many variables. Pi is good. Pi is a number. I have r, which is exactly what I want, but I have h coming up here, and that makes it one too many variables. But I have this relationship that h is the same thing as 100 over pi r squared. So, for simplifying, I'm going to have, okay, 0.14 times 2 is 0.28 pi r squared. Let's go ahead with 0.07 times 2 is a 0.14, and then we'll have pi r, and then where I have h there, I'm going to substitute in 100 over pi r squared. So my last step here, that first piece is all simplified, 0.28 pi r squared, plus, 0.14 times 100 will be 14. Pi will cancel out, so we won't have pi there. And then r divided by r squared, that's going to leave an r in the denominator. So I'm going to have that 14, but it'll be divided by r. And then that's completely simplified. So again, if you don't know these formulas, you can look them up. You should have seen surface area, volume, and area formulas before this class, but getting a refresher is always good too. Again, if it's not memorized, then this is the route that I usually go, is just kind of deconstruct it and think about how the pieces would go together. And again, with these, just to emphasize, you're getting to these functions where you have a single input, so just make sure you only have one variable at the end. If you have too many, like we would have with that h there, look back and see if there would be a way to substitute in.